Before we get started, I'd like to do a simple experiment with you. Think of a whole number between 1 and 10, and don't tell me what it is. You may know how the following works, and if you do, just hang in there. You'll get your chance to impress the nearest person by knowing what I'm about to explain. Take your number and multiply it by 9. Don't worry, 2 more steps and I'll get to the point. If the number you ended up with has 2 digits, please add those 2 digits together. Whatever number you have now, subtract 5 from it. I'm not trying to impress you by knowing that the number you're left with is 4, but it is pretty neat. The way this works is simple enough, once you know it. Any number between 1 and 10 multiplied by 9 will result in a number whose digits, or digit, will total the number 9. A little extra step subtracting 5 for showmanship and short-term memory management, and I know you have 4 left over. But what does this have to do with security? Well, using some simple instructions, I was able to get you to do something I wanted and give the illusion that you knew something I didn't, when in fact the opposite was true. This is the goal of any magician or hacker. The biggest difference is that one tells you they're tricking you and you pay them, and the other doesn't tell you they're tricking you and you pay them. So how do you protect yourself from hackers and other con artists? You don't have to be a security specialist or an IT person. You just have to understand 2 important things: risk assessment and practical engineering. That sounds much more complicated than it is. Risk assessment is just what it sounds like. You want to try to fit or slightly exceed the necessary security for any given thing without going too far and creating inconvenience or worse. The practical engineering piece is simply understanding what techniques you might apply to keep a device secure, and that doesn't mean you have to have any intimate knowledge of computers or electronics at all. Do you know what the most secure device on the internet is? It's the device that isn't connected to the internet. The security world has a term for this. It's called air gapping. If there is no way to communicate, there can be no malicious communication. You can apply this unidirectionally to get information without giving any away, but I'll talk about that a little bit later in the video. I want to start with the best thing you can do to keep a device safe, especially one that might be crucial to your daily routine, comfort, or safety. Don't connect it to the internet. You may think that's obvious, but how many of you have a Nest? What you have there is an internet-connected device that controls a box of fire in your home. Okay, maybe you have electric heat, and the worst an attacker could do is crank your heat to 95 degrees while you're at work. Imagine what that alone could do not only to your electric bill, but the amount of work the grid has to do if yours is one of thousands of homes or more. I don't want you to think I'm saying your Nest or other device isn't safe, but perhaps consider the security of everything around it and what you might need to do if you had to disconnect it. I do not own a Nest, but I would imagine it works just fine offline if it needs to, and it has a good reason to be online in the first place beyond just your desire to make sure the kids haven't touched the thermostat. There are some utility providers that can, if you allow them to, control your HVAC system remotely to make the energy usage the most efficient for both you and the grid. I might talk more about that in another video, but I'll spare you in the interest of the main topic. I want to take a moment to talk about a recent conversation I had with an extremely established security specialist. I won't disclose who this is for sake of privacy and security, see what I did there? But suffice it to say, he's walked every road from cryptography to beyond enterprise information security. He made a few suggestions upon reading the first draft for this video that are extremely important and valid, which I appreciate very much if you're watching. First, when we talk about security, consider how fluid the definition is. Being secure is a state of mind more than a static condition. Your house is made up of layers of thin material containing pockets of air. It's amazingly easy to break through any point if you're so motivated. I bring this up because the gentleman I spoke to said something I thought was absolutely profound in its simplicity. Houses are not meant to be secure. What he means by this is that a house is a shelter from the weather and a place to be and keep stuff. The functional purposes it must serve make turning it into a fortress nearly impossible. No lock is unbreakable. The nice thing is that for most people, that's just fine. Someone isn't likely to take a fire axe to your wall in order to steal your television for a multitude of practical reasons. So as I continue with this video, I want you to remember that knowing how much someone wants to do something is more important than trying to prevent it. I will be doing a series of these security videos to talk about the 3 pillars of cryptography: what you have, what you know, and where you go, as well as other more in-depth topics for those interested in data and personal security. So I don't want you to watch this video and think that the chances of being targeted by an attacker or surveillance concern is high. It is just the opposite for most people. It's not worth the time and resources unless the reward is high enough to offset those costs many-fold. But as we progress into a more interconnected infrastructure, I want us to be fully aware of the trades we make and what to do when those trades don't work out. I want you to have backup controls and to consider what offering up your information to a broader geography might entail. I certainly don't want you to think I'm asking you to disconnect or throw out your Nest. It's a neat little device with a lot of great features to help save you money and help us all live better. There are other devices that aren't nearly as secure or robust as the Nest, however. Smart thermostats and other devices alike. This is one reason that I do teardown videos. I've done some experimenting on a few smart plugs, for instance, and found some surprising security holes. I'm not an InfoSec specialist of any kind, which makes the situation even more impactful in my mind. I got into this smart plug's shell with very little effort or tools after listening to it send out my Wi-Fi credentials in plain text on first configuration. I was able to tell the firmware to send continuous on-off commands to the relay, and eventually some part of the circuitry gave up. This could be a minor inconvenience and cost you another plug, or it could be something with a bigger draw or a less obvious attack plan. Again, going back to I can now control whether or not power is being used in your home if I get into this device. And let's not overlook the first step I took either. This device gave away my Wi-Fi credentials when I set it up for the first time. It's a small window for an attack, but not to a computer and a persistent war driver. It may be a very small risk, but this little plug might have just let an observer onto my network that I wouldn't detect until something changed, and maybe not even then. Why? So I can turn off the living room light from my office? When is it okay to trade comfort for safety? The answer is it's never okay. You can have both, you just have to think about it a little harder sometimes and ask yourself, can I do this without exposing myself to harm? Stepping back from simply not connecting your devices to the internet, there are ways you can still have security and still be able to turn your devices on or off remotely, if you insist that's what you need to do. I think a better approach is simply, if a person is in the room and it's dark, turn on the light, otherwise leave it off. But I'm not against all novelty. I will never be a fan of allowing video to be streamed from a live camera where a neighbor or my own habits could be determined by a passive observer. If it's security you're after, don't expose yourself to more sophisticated criminals in an attempt to stop a porch pirate. I'll have a video dedicated to that topic later on. A criminal might be able to accomplish the same data gathering by sitting in their car somewhere for a while, but imagine what hundreds or thousands of camera feeds from the same neighborhood and some machine learning might enable criminals to figure out. So I will talk about internet-enabled controls, but I will never support streaming video, no matter how good you think the encryption is. The fact of the matter is, in order to have high definition or better video, you must have bandwidth. When you increase bandwidth and bitrate, you increase the computing power needed to encrypt. There comes a point where you start making compromises. Sure, there's compression. Sure, there's lower frame rates. But those are not guarantees that encryption hasn't suffered by any stretch of the imagination. Having said all that, I will talk about being able to read status information and send commands to your system over the internet, as this is much less risky in general. The first obvious line of defense for your network is a firewall. But if the traffic the firewall is inspecting looks to be normal internet traffic or a streaming video, that's not going to do you much good. And there are clever enough hackers to mimic those packets or even just inject a malicious payload into existing traffic. It's not common for these attackers to go after John Q. Public, but we're entering a new age of knowledge and tension. It's worth at least considering. As smart homes grow in number, attackers will begin to see larger opportunities for large-scale attacks that you may not readily consider. Going back to the massive power draw attack, if an attacker could turn on thousands of houses' HVAC systems during peak hours on the grid, they might be able to do some damage, and that's not great. The same can be true for a multitude of other devices, especially ones with motors and high starting current. So, how do you get around this? You simplify and obfuscate. Numbers rarely mean something unless they mean something. So let's say you want to know the states of all the switches in your house. If you use a 0 for every off and a 1 for every on, you have a binary number with a decimal representation. If you have an endpoint called lucky number that spits out just this number and you have a client interface that can contextualize it on your own side, that's a pretty safe approach. I'm not just trying to give you security through obscurity. That's not always good. This approach is also taking into consideration the risk assessment and being one of several layers of security such as Secure Socket Layer. I'm not going to get into SSL in depth, it's the thing that makes HTTPS possible among other things, but if you're hosting a website of your own, you should probably already know what it is and how it works. If you don't host a website that can control your house on your own. Now, I want you to think outside the box as much as possible. I did a video some time ago showing how to send UART between two Raspberry Pi microcontrollers. You don't need to know what any of that means, but if you do, it's very helpful. Sometimes the oldies are goodies. Right now, if you wanted to turn a light on in my house remotely, you would need to know the device ID of my phone, my passphrase, which is 4 words, the endpoint that receives the command, the timecode seeded header token generation method, the command format, and have some physical path to my system. If any of these things are not satisfied, there's only one other possible way to hack into my system, and that is to walk into my home and plug a USB cable into this device using the appropriate software to rewrite its code. The reason for this is that this device listens for commands from an MQTT broker and relays them over this serial UART connection to the isolated network my smart devices are actually on. This device doesn't have an operating system as you know it. It simply executes those instructions. So if you can't pass the verification methods to get the MQTT message in the correct format with the correct time-coded token, you'll never get into the real smart house network. I'll do a full write-up of my network diagram and make it available to patrons, but this would be for those who understand enough to connect two microcontrollers together with a UART connection. So what can you do if you don't understand those things? Well, for starters, you could give up the novelty of controlling or monitoring your home actively rather than relying on security systems and emergency services, but if you're not likely to do that, consider consulting someone who understands how to properly secure your network and reduce the amount of information you're broadcasting over a communication medium from your home. Another thing to consider is unidirectional or one-way communication, read-only. If you just want to see the status without being able to alter something, that's a good compromise in many cases. I will always push those who cannot ensure they understand how the bungee cord works to not jump off the bridge, but if you're going to, at least Google it before you do it. Air gapping is the safest security measure possible. Don't hook it up. And there are still ways to communicate between air-gapped devices if you're a clever programmer or tinkerer, so be aware of this as well. Many people consider the QR code to be a good way to ensure only the information that should go to a device can go to a device, but unless you're the one creating the QR code, you can't be sure what's in it. If you're not someone with technical knowledge, don't scan QR codes from weird sources. If you are someone with technical knowledge, use a tool to display the QR code in plain text before you actually try to use it to verify its data. Although even this can be sketchy if the site it's likely pointing you to is. In summary, if you don't need to send information over the internet, you shouldn't. If you do and don't understand the risk, it could be more than your own safety you're risking. Remember the passive observer on the security camera example. We've used closed-circuit security in commercial and industrial applications for decades for a reason. If the thief got to the DVR, you had much bigger problems. Also, hide the DVR better. Also, don't be so eager to enable remote control of electrical devices, because there are risks you can't imagine to the greater population by doing so, not to mention the personal risks you may not think are as bad as they are. In distributed denial of service attacks, for instance, an attacker will use several remote machines to execute an attack on one specific system. If an attacker can control your power usage in any way, you could be a zombie for a multi-layered attack on the power grid. And consider the duty cycle or lifespan of these devices and services as well. Degradation in service quality is also a security risk, perhaps one I'll discuss in a follow-up. For now, I'll leave you with all this to think about, and if you are thinking about it, please leave me a like and consider subscribing if you haven't already. I'll be getting back into some smart device disassembly soon, where I'll talk more about some of these security points as I explain how they work. Thanks for listening to me ramble, and I hope you'll join me for future videos as I continue exploring smarter circuits.